hydraulic jack works by moving the lever up and down repeatedly. Note that it only takes a little bit of force to move the entire lever down.
Despite little force input, it is impossible to move the piston back in its original position.
So for this system, the prime mover is me, and I am also the pump.
The reservoir filled with hydraulic fluid is located here.
So, the way the valves work is that in here there are two check valves. Here's a picture to demonstrate how they work. And when the lever is in the upright position, fluid from the reservoir enters this piston right here, and since they are check valves, they only flow in one direction. When the lever is pressed down, fluid exits out this valve into our large piston up here by my face. So, again, when the lever is in the upright position, fluid enters through here, this valve, and when pressed down, fluid exits out this valve, pushing the piston upward.
Since we can't see through this jack, I made makeshift conductors. This is where the conductors would be. The arrows represent fluid flow.
Fluid flows down through the check valve, up the other check valve, around, up to the piston.
Fluid fills the cavity, moving the piston up, and with that, the cycle continues.
How big, how... It's too bad we can't get a clear shot of the reservoir.
So me and Erik walking around campus, we were lucky enough to stumble upon construction workers working with a hydraulic lift.
We asked the operators to come down and show us what's underneath the hood of the system.
To start, from here, you can see multiple conductors and valves. The conductors they use for this lift are hoses.
Here you can see the construction workers lowering the lift. At the right-hand corner of the screen, you can see a large piston actuator.
It's kind of hard to see, but there are actually many types and sizes of valves and actuators located around the entire system.
This is what we found underneath the hood of the system. This large cylinder is the prime mover, which is a diesel engine. These red canisters are filters. This is the pump assembly, which is connected to the prime mover. Almost all of the conductors they use are hoses.
The construction worker told me to come around and showed me the reservoir. Here you can see how large the reservoir actually is and how much fluid is needed for the system. So Erik drove both of us to Princess Auto, and we found a bunch of hydraulic fluid, some valves, and we were checking out everything.
This is the log splitter.
Here, Erik points out the gasoline-powered prime mover.
This is the actuator, which is a large piston,
which pushes the wedge forward,
which crushes the log. Here is a conductor, which is a hose,
and attached is a valve. Here, Erik demonstrates how fluid enters the pump. So here is a nice clear shot of the reservoir, filter, and pump.
The old fluid comes from the actuator, through the hose, into the filter, into the reservoir, back to the pump, and into the hose.
You can see here that the hose is made to withstand 300 psi. And there you have it. the hydraulic jack, the hydraulic lift,
the log splitter.